Okay, so the quiz, I want to really focus a lot on projectile motion because that's most of your quiz, but we'll talk about the forces too. So actually 7 questions on your quiz are from chapter 3. I'm going to call it chapter 3B. That's just projectile motion, not vectors. So that was on the exam, not vectors on the quiz. And then 3 of those questions will be from chapter 4A. That's going to be 2 calculations with forces in 1 dimension. So of these, 2 are going to be calculations similar to ones we did in class today. We can do some of those today. And then 1 of those will be a conceptual question, similar to some of the questions like we had on the concept test or from the old test. So we'll look at some of those and get a feel for, what they're going to be like. But your first few questions are going to be a question, it's projectile motion problem, where you have to figure out things like the time in air, the x range, the horizontal range, or the vertical range that you have for that projectile. So you need to be ready, just like you will for exam number 2, you need to be ready to do that on the quiz. So it's going to be a lot like the exam in that way, where you'll have one question with several parts, not a free response, it'll be multiple choice, but you'll still have several parts in the same question. If you look back at my old exams where I used to not have free response, it's going to be like that. For example, let's see, this is fall 20. Can we work through this one? Is this okay? Fall 20, because this is going to be like the problem that's on your exam, on your quiz. So you kick a soccer ball from ground level at an angle of 30 degrees at a speed of 20 meters per second. What is the ball's maximum height? Listen, the first thing that you should do is just to calculate the x and y components of v naught. So v naught x is equal to v naught, which is 20 meters per second, times the cosine of the angle 30 degrees. And then v naught y is 20 sine of 30. So that's equal to 10. Is equal to 17. I find if you just calculate those right out of the gate, it makes it a little easier. And then I want to know the maximum height. So we're dealing with a situation where I have a ball that goes like this, and I want to know what is this height right here. What is that y height? And remember, this is exactly the same as we had on exam number 1, where I have a ball that goes up and comes back down again. And I want to know what is the height of that projectile. The x motion is completely separate, right? Yes. So if I want to find that, there are 2 steps to it. The first is I need to find the time. In order to find the time, I say that v top in the y direction is equal to 0, and that's equal to v naught y plus ayt. So that's 0 equals v naught y, I've already found that, is equal to 10 minus 10 times t. So t, that's at the top of the trajectory, is equal to 1 second. I know at the top of the trajectory, the velocity in the y direction goes to 0, so I can figure out the time by using this equation to figure out what is the time at the top of the trajectory. And then, now that I know that the time up here is 1 second, then I can figure out what is y. Y is equal to v naught y times t plus 1/2 ayt squared. That's going to be v naught y, which is 10 times 1 second. Notice I'm using this time. You have to choose the time to use. In this case, since I want to know the time at the top, or the position at the top, I use the time at the top. 10 times 1 minus 5 times 1 squared, that's equal to 5 meters. So that's going to be the answer here is A. Okay? But then you have a couple other problems that are parts of this. Looks like I just had 2 here. There's a 2-part problem. But I'm pretty sure on your quiz I had 3 parts. I might have 2, I don't remember. But just be prepared. I mean, I could have made this a 3-part problem. I could have had this be a separate problem, finding the time to get to the top or the time for the total trajectory. To find the ball's velocity at the top of its trajectory, to do that, well, you just have to think about it. Because at the top of the trajectory, which does it have, an x component or a y component or both? only the x component, right? I'm not sure who said that. One of you two, I think. Yes. Okay. So only has the x component because the y component is 0 at the top. So I only have my x component, and that x component is equal to the initial x component. I know that's true because ax is equal to 0, and so the velocity doesn't change. And I can go back to where I found my x and y components of v0. So the answer is a 17 meters per second. Be prepared to have those questions, 2 or 3 questions, and you need to know them lickety split. It'll really help you on the upcoming exam because you're going to see those again on the free response. You're going to see this problem on the free response, going up and coming back down again. And I want you to know it cold. Know it cold for the quiz. That'll help you. Yes, y'all can do that for the quiz. And then there are some different types of projectile motion problems. Since there are 7 questions on projectile motion, I would expect to see them all. You might not see them all, but I would expect to. They're all a little bit different in the way that you approach them. This one, we did this one in lab, right? Where I have a projectile that goes off at a horizontal velocity. In this case, the initial velocity in the x direction is just equal to the initial velocity because there is no y component to the velocity. So v0y then is equal to 0. And I want to know what is the x range, what is this distance. Well, in order to find that, it's going to be equal to vx times t. I know what vx is, it's 10 meters per second because the acceleration in the x direction is equal to 0. That means that this value doesn't change. That's what acceleration is, right? Change in velocity. And so I just need to find the time. The time for the ball to get from right here to right here, or rather from right here down to here. And in order to solve that question, I imagine, okay, I have a ball that is 80 meters above the ground. That's the cliff height. How long does it take to drop 80 meters? We've done that problem too. You had it on exam 1. That is y equals, let's see, v0y is 0, so I'm just going to leave that term off. So y is equal to 1/2 ayt squared. That's negative 80 equals negative 5t squared. What's that? My brain's not working today. Oh yeah, so t is equal to 4 seconds. Once you get t equal 4 seconds, I can put it in right here. 4 times the, right here. 4 times v0x, 4 times 10 is 40 meters. So D is the right answer. Okay? Let me turn this light down. Now do that for me? Did you do that for me on Wednesday? Without even really thinking about it. That's where you want to be before Wednesday. That you can do these without even really thinking about them. That's where I know many of you are probably not there yet, but that's where I want you to be by Wednesday, okay? All right. Let's look at some others while we're going. You'll have 3 or 4 calculation problems, and then several conceptual questions. You're probably, like for example, you might have one like this. This is the x position as a function of time for a projectile. This is an object that's launched horizontally and follows that trajectory. The x position, what you know about that is that Vx is constant. That's true actually for all projectile motion. And so if Vx is constant, that means that the slope of this graph doesn't change. That means it has to be v. Now follow me on that. That since the slope doesn't change, that means its velocity doesn't change. It's exam 1, right? A lot of exam 1 coming back in exam 2. We're just applying them in slightly different situations. You'll see questions like number 8, that is conceptual questions. I'm pretty sure I have one of these where I have multiple ideas and you have to tell me which ones are true. Let's go through this and see which one is true. Watch the words, okay, because the words are the important part of the question. The velocity of the ball at the top is 0. True or not true? You're right. Not true. The velocity in the y direction. If we wanted to correct this, we would say the y velocity of the ball at the top is 0. But as it's written, not true, because it does have a velocity in the x direction. The horizontal component of the velocity is greatest at the beginning. No, not true. In fact, the horizontal component of velocity is constant. That's how I'd make that statement correct. The acceleration is positive during the second half of the trajectory. No, not true. The acceleration is always minus 10. Going up and coming back down again, the acceleration in the y direction is always minus 10. And the ball's speed increases as it travels upwards. Now, what if it was downwards? Would that be true? Yeah, you're right. So a couple of reasons. I could make this correct in a couple of different ways. I could say that it decreases as it travels upwards, or I could say the ball speed increases as it travels down. However, notice that if I did velocity here, that would no longer be correct. You understand why that is? Because as it goes down, the velocity gets more negative. So I would write speed. I wouldn't trip you up in that way. But if it said the ball's speed increases as it travels downward, that would be correct. Okay, so what do we got? Oh, none of those are correct. E is the right answer. Okay, so that's a good flavor for, the first 7 questions. You have particular questions that you want me to deal with, and then we'll get into the force stuff. That's the newest things, but the fewest questions on the quiz. Only 3 questions. You can probably even guess what they are. On this exam? Sure. Okay, so let's just write down what we know and don't know. I have a ball that I'm kicking off the top of a cliff. It's following this kind of trajectory. This was that third type of projectile motion problem. And remember, there are 2 types, up and down, same level. One up, going off at a horizontal. And then this one, which we also did in lab, where I'm shooting at an angle from some height. Usually on these, I'm going to give you the time, because to find the time, as you found in lab, is fairly difficult. You have to use a quadratic equation. Anyway, as an initial speed, I'm going to go ahead and figure out what is v naught x, v naught y. V naught x is 25 cosine 30. That's 22. And then v naught y is going to be 13. So I did 25 cosine of 30 to get v naught x, 25 sine of 30 to get v naught y. And that's all I really need to know right now. But for number 5, I want to know the magnitude of the ball's velocity at t equal 5.4 seconds. I don't know where t equal 5.4 seconds is, but let's say that it's right here, for example. It might be before the peak. I don't really know. But at this point, I'm going to have a velocity in the x direction, like that, and a velocity in the y direction, like that. For number 5, I have to figure out both of those. I already know Vx, in fact. And then determine the resultant of those 2 vectors. So I'd figure out Vx and Vy, and then I'd do the square root of Vx squared plus Vy squared. That's what it means when it says the magnitude of the ball's velocity. It doesn't say anything about x velocity, nothing about y velocity, just the velocity. And I want to know the magnitude. So we're reaching back to exam number 1, chapter 3a, using vectors, finding the x and y components, and then finding the sum of those vectors. So at t equal 5.4 seconds, I know Vx is equal to 22. I know that because that's v naught x. And ax, the acceleration in the x direction, is 0. So the velocity doesn't change. To find Vy, Vy is going to be v naught y plus ayt. That's going to be 13 minus 10 times t, which is 5.4. 13 minus 54, so minus 41. Minus 41 meters per second. So I was right, by the way, in assuming that I was over on this side of the trajectory. How do I know that? That I'm over the hump, so to speak. Right, because the velocity in the y direction is negative. It went up, and now it's coming back down again. And I have vectors that look like this, 22, 41, and I want to know this vector right here. I can think about this as a triangle. Just moving that vector over like that. And now I do the square root of 22 squared plus 41 squared. I don't know. It's either C or D. Let's see. What is it? D? Okay. So that's equal to 47. Y'all know how I knew it was either C or D? Because remember from chapter 3, this has to be somewhere between 41 minus 22 and 41 plus 22. Remember how we had that problem where what's the sum of these vectors is in between such and such? And so it has to be in between. It can't be less than, what is that, 19 or whatever, and it can't be more than 63. So it has to be somewhere in between those. So it can't be this or this. Okay? Elena, does that help with that one? The key here is figuring out that I have to know these two vectors. That's probably really the question you were asking, right? That's the trick for it. It's not a trick, right? It's just bringing together all these different things. Physics builds on itself. This entire course, especially these first 4 chapters, will build on themselves. So be prepared for that. Fortunately, in the 3rd and 4th exams, there's less of that. And that's why those 3rd and 4th exams are easier than the 2nd exam. But this one's so difficult just because it does depend so much on chapter 1. That's why I say it's the most difficult exam, because it's really like chapter 1 or exam number 1 again with more. Okay. Yeah, Jonas? Right. Yeah, so you asked, why do I use 22 here? And it's because I had 22 here. Right, and like you said it, the x component is always constant because ax is 0 for our projectile motion problems. Now, when we have a force acting in the x direction, that's no longer true. We had some problems like that in class today, and we'll look at some of those. Okay? All right, let's look at some chapter 4 problems. 1D problems, so just to give you some ideas, like for example, this is fall 20. We would have something like number 13. That was from their concept test today. You would not have something like 14. The reason you wouldn't have 14 is because, one, this is on an inclined plane. It's a 2D problem, two-dimensional problem, not going to have 2 dimensions. You also see that it's about frictional forces, not going to have frictional forces. So not that one. 15, 16, not 17. The reason I know not 17 is because it's about friction. And though we'll get to friction on Wednesday, we're not going to have it on our quiz. Let me just show you. We can come back to some of these, but let me just show you, for example, number 18 we could have. Number 19, maybe, except it has this, so not going to have that. 21, no. Why not 21? Is an inclined plane, right? 20, yes. In fact, we did a very similar question to number 20. We'll come back and do that. 22, not this one. The reason is because I have a force in the y direction, and I also have a force in the x direction. No two-dimensional problems. As you're preparing, if you have a question about a particular exam or a particular question or set of questions, just shoot me an email. I'm sorry that I can't say work up to this point, that the questions sort of get interspersed. Usually I have all of this chapter or none of it at all, but just the way the schedule worked. Number 23 was a 2D problem. Not this one, not this one, not this one, because it's a holdover of 24. And 26 is looking at F equals MA. So that's sort of a flavor for it. In a bit, we can look at some other exams, and I'll give you a flavor for those other exams. But this is the fall 20 exam. Let's look at, for example, number 20. Let's look at number 20. We did one of these today. We did a couple of these today, right? Remember the elevator problems? So I have an 80 kilogram block. 80 kilograms. Let me put my units on there. Remember, you have to be careful dealing with masses and forces. So this object has a mass of 80 kilograms. It has a weight of 800 newtons. Remember, Fw equals m times g. So 80 times 10 is 800. You'll get the hang of that. I know it's sort of strange right now, but we're using sometimes masses, using sometimes weights, and you just have to get used to it. I drew my figure. Now I'm going to draw my forces. I have two forces. I have the tension, and I have the weight. So I draw my forces. Those are the only forces I have. I'm going to write Newton's second law. I don't have to worry about resolving into components. We talked about that today. We'll see it next time, but not for your quiz. I just write Newton's second law. Sum of the forces equals ma. That's Ft minus Fw minus, because the weight vector, Fw, is down, so it gets a negative value. That's equal to mass times acceleration. Ft, I don't know that. That's what I want to know. Minus 800 equals to the mass, which is 80 kilograms. This was newtons. Times the acceleration. Acceleration, you gotta be careful with the acceleration. The sign is 4 meters per second squared, but be careful here because it's descending at 4 meters per second squared. That means that my acceleration, because it's speeding up and it's going in the downward direction, my acceleration is negative 4 meters per second squared. Look for language like descending, meaning it's going down, or going in the negative y direction. Look for those sorts of words. All right. Then I can solve this for Ft equals 800 minus 320. 480. So D is the right answer, 480. I also want you to, can I say something right quick? I want you to notice that if you got that wrong, like if you got some of those signs wrong, like for example, if you had a plus here, you would have said 1100 newtons, but that would have been wrong. Or if you had, what else? Or if you didn't have this written right, you would have put 320 here. There are a variety of ways to get this wrong. So be careful with your signs. Almost every way of getting it wrong has to do with the signs. And the signs can be made wrong where if you get it wrong here, giving your vectors the appropriate sign, and then also right here, giving your acceleration the inappropriate sign. Can y'all be careful? Because I've seen really good students that know how to do it, and they mess up, they just get the wrong sign. So I'll just give you that as a warning, that to be careful with that, okay? Elena? Yeah. Yeah, of course. Fall what, 18? That's 20. Okay, 22 you said. Yeah, this is a similar question. This was the second type of question I want to look at. We did one today. This is sort of like the rocket problem we did today. You remember the rocket problem with the thruster engines? I have a swimmer, a pretty blocky swimmer, I would say. She pushes on the wall and accelerates at 4 meters per second squared. Okay, so I have this swimmer. She's pushing off of the wall, and she pushes off with a certain force. I'm just going to call it F. That's the force that I want to know. And then she also experiences a frictional force, just drag in the water. And I'm going to call that, I'm going to call it a lowercase f. We haven't seen that yet, but I'm going to start using that notation. The lowercase f will always be like the resistive force. And I know that this is equal to 100 newtons. I don't know what that looks like. It doesn't look like 100 newtons. Okay, that's 100 newtons. And she gets an acceleration in this direction equal to 4 meters per second squared. It's positive. So now I apply Newton's second law. I've drawn the picture. I've labeled all the forces. And I say the sum of the forces equals MA. That's F minus 100. My pen's messed up. I don't know what's up. Minus 100 equals her mass, which is 60, times 4. So F is equal to 240 plus 100, which is 340 newtons. Okay? Elena? Okay. Okay. I think that's, hold on just a second. Let's just double check that's the right answer. 22 is D. Yeah. Oh, the 60 is right here. That's the mass. It's just given. Yeah. Madam. Okay. Okay. So in this case, let me state this. Friction, our resistive force, we saw it today with the rocket. A resistive force, like friction, always oppose the direction of motion. We'll see that on Wednesday. So see here, the wall of the pool is right here. Any of y'all ever swim? Like medically or whatever? Yeah, so you push with your feet off the wall. And so this is the force that you're pushing with your feet. And then this is the force that's pushing back against you. So she's moving in this direction to your right. So the frictional force, or the resistive force, opposes that direction of motion and pushes back in the opposite direction. Okay? Can we do some more? Let's do some more. Any particular ones you want to do? Okay, so as far as the quiz, not going to have one like this. The reason I can tell is because I have forces that are in 2 dimensions. In fact, we had a question we were supposed to do like that today, but we skipped over it because I wanted to work on quiz stuff. Likewise here, I have a force that's off, not on X or Y, so not on the quiz. So I can identify those as not being on the quiz. Not on the quiz because I got this inclined plane. This was related to that. This was related to that. By the way, the inclined plane will be your other free response question. It'll probably just be those 2. Projectile motion and the inclined plane. Probably have like 4 on each. Yeah. Oh, yeah. Yeah. Places. So you have 3 equal masses, each with mass m, and you exert a force on one of the masses and get an acceleration a. And now you exert the same force, you combine the 3, and you exert the same force on it. So let's write the first equation. F equals m. If I apply this force to this mass, I get this acceleration. Now what happens if I apply the same force to a mass that is 3 times as big. What happens then to the acceleration? Well, I've increased my force by a factor of 3. It's the same force as it was before, so is my acceleration going to be smaller, bigger, or the same? Smaller, bigger, or the same? I have a bigger mass, more massive, but the same force. M has gone up, but the force has stayed the same. Is the acceleration going to be bigger, smaller, or the same? Smaller. Right, so if I have F equals ma, if this remains constant, if this goes up, this has to go down. It's a direct inverse relationship. If one goes up, the other goes down. And A has to go down by a factor of 3. So A is going to be 1/3 of its original value. Let's look at some others. Yeah, I mean, as far as F equals ma, like M and A are inversely related. Well, let's look at a different one. I mean, I have these types of problems in almost every test, so. Oh, I got the momentum on that. No. We'll come back to that. Number 12 is a good example of this. 2 objects, A and B, experience the same acceleration. However, object A has twice the mass of object B. If it has twice the mass and the same acceleration, what does that say about the force on object A? Is the force on object A bigger or smaller? It has a bigger force because it has twice the mass, but it has the same acceleration. Is the force on object A twice as big or 4 times as big? 4 times? What do y'all think? Is this a linear or a quadratic relationship between F and M? You know what I mean by quadratic? It means is the variable squared, right? Like t squared, that's a quadratic equation. That's what a quadratic equation is, like that. 1/2 at squared, that's a quadratic equation. This is a linear equation because it's not squared. So if I double M, what has to happen to F? I double F. Whatever I do to one side, I do to the other. In this case, this is a linear direct relationship. When one goes up, the other goes up. I would say that F is directly proportional to M. Well, no, that means the acceleration is the same for both. That means the force on object A is twice the force on object B. You can draw a picture on this too. Like this is object A. It has a certain acceleration. This is object B. It has the same acceleration. Because object A has a bigger mass, you need a bigger force to give it the same acceleration. Because F equals ma. Because in that other one, the acceleration was constant, but in this one, the force is constant. Okay? Because you see that in this one, M, or rather A, is proportional to 1/m. If you remember, that's how we wrote Newton's second law. In fact, actually, that's what Newton said, that the acceleration is inversely proportional to the mass, and that the acceleration is proportional to the force. And then he put those two proportionalities together to get Newton's second law. Okay. Newton, when he wrote Newton's second law, he said that the acceleration is inversely proportional to the mass. And the acceleration is proportional to the force. I'm sorry, my pen is not working today. And then he put these two proportionalities together to say that A is equal to F divided by M. It's important, like Newton's law is important to you, especially if you're pre-med, you see it on the MCAT or whatever, or even if you go into medicine, depending on what you do or physical therapy, that these things are important. They really are important to your graduate studies. But what's also important is that you're able to look at an equation and understand the relationship. Is it an inverse relationship? Is it a linear relationship? Inverse, one goes up, the other goes down. A linear relationship, if one goes up, the other goes up, or direct linear relationship. And is it linear or quadratic or something else? Linear means if it increases by 2, it increases by 2. If it a quadratic relationship would be if it increases by 2, this other variable increases by 4. I want you to be able to look at an equation and understand the relationship between the variables. That's important for you and for me. Elena? On 18? What number? This one right here? Oh, okay, yeah. Okay, yeah, this is another type of those problems. Honestly, I don't remember what the conceptual was, the conceptual question that you have for forces, but these come up a lot, so it could be one of these. You push an object of mass m, initially it rests with a force and cause the object to travel a distance in a certain time, da, da, da. If you double the force, what happens to the distance? So I know F equals ma. So if I apply a force, I get a certain acceleration. And x then equals 1/2 a t squared. Notice I left v0 t off. That's because it's initially at rest. That's why I left that off. And also notice that a is no longer -10. I know that my pen is not working. That's an a right there. So if I double the force, that means I double the acceleration. And if I double the acceleration, what happens to x? X gets doubled. What would happen, for example, if I doubled the time in this second equation? What would happen to x? Be a factor of what? 4. Right. Be a factor of 4 bigger. That's called a quadratic relationship. Okay? It's kind of important for you to look at an equation and understand the mathematical relationship. Not many people can do that, but y'all can. You'll get the hang of it. It's going to come up a lot in the semester and next semester too. Okay? What else y'all want to do? Sorry, what did you say? Was that a snarky comment? What did? Oh. No, we haven't gotten the third. No, it doesn't come up. I mean, we had it in class today, the normal force. No, it doesn't come up. We'll see it again on Wednesday, though. All right? How are y'all studying? That's the way to study. I would print them out. What? About physics? Man, you are amazing. That means you're almost ready, right?
Yeah, but I think that before every exam
Oh. Say that. That makes me sad. I'm gonna cry. Yeah. I usually say like, I mean, 60? No, I go back farther than that. Um, they really sort of, probably 11. And I just say that because, or maybe, I usually 14 is probably where I pick up. But all these exams are going to be really similar, you know? I'm joking when I say you should memorize them. You can't memorize all those questions. But if you work through them enough times, you will memorize them, I suppose. But yeah, Austin. No, you just waiting. All right.
You reviewed 10 on exam 2 2016.
Oh, I hated this problem. So can I not? Is that okay? It's not going to be on your. It's not a very good problem. No, 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 no. I remember that problem. It was. I'm not even sure that it's a correct problem. No, they could all have the same speed because they're just at different angles. Yeah, the answer is this is A. It's just that you have different angles. Yeah, no, this one is okay. Um, it's not on the quiz tomorrow, but you just have different angles. Like for example, A might have an angle of say 60 degrees, B would have say 45 degrees, and C would have say 30 degrees. My pen is terrible. All right. Jonas?
So I'm actually terrible at determining graphs. So like a x versus t graph.
I'm pretty sure there's a graphing problem on it. So for projectile motion, if I have a projectile that follows a path like this, these are what the motions look like. If I have this is Vy versus t. If it starts out big and positive, goes to 0, and then gets big and negative, that's what the Vy versus t looks like. The Vx versus t looks like this. And then the y versus t, so sorry, starts out with a big slope, goes to a 0 slope, ends with a big negative slope, so it looks like this. And then Vx versus t, excuse me, x versus t. It has an unchanging x velocity, so it's just a straight line like that.
Kind of like lab 3.
Lab 3 and exam 1. But just applied specifically to projectile motion. I don't remember exactly. I'm pretty sure there's a question like that on there. Or maybe I'm thinking of the lab midterm. We have lab midterms tomorrow too. That's exciting too, right? Y'all have questions about lab midterm? Do you know that's this? Oh no, that's this week. You already what? Okay. Other questions? No, we're getting to that on Wednesday, but not on your quiz. So any questions like that? No. All right. That's you can start off too.
The x for t graph telling us that it's constant or is it 0?
It says that it's constant. If it were 0, it would look like this. It would be along the origin there. Haley? Oh, I'm sorry, Jonas.
And then the x versus t is telling us as well that it's constant.
Right. Yeah, so whatever the slope, let's say that the slope of this thing is equal to 2, that would mean that this value right here would be equal to 2. Right, because the slope is the velocity. Haley?
Is there going to be a problem when you get the initial speed and the angle that the ball is kicked, but we just find the y-max and the x-max?
Oh yeah, absolutely. That's problem number 1. Do you want to do that? We did that earlier, but I can do it again.
In the homework part where that's it's number 9.
Number 9 in the homework. Okay. Just a second, I'll pull it up. Did y'all have a good weekend? Past weekend? All right. Just cried. I said just cried over the weekend. No, and tailgate, yeah. Oh yeah. So this is problem number 1. It is this problem. Let's go through it again, okay? It's on your exam 2, too. Problem number 1 on exam 2. I like to draw a picture. I like to go ahead and calculate V naught x and V naught y. V naught x is 10 cosine 30. And V naught y is 10 sine of 30. This is 8.7. This is 5. So those are my initial x and y velocities. And I want to know the height, y, and I want to know the x. The first thing to do is to find t-top on this problem. To find t-top, I say that the velocity in the y direction at the top is equal to v naught y plus ayt. That's 0 equals 5. I got that from up here. Minus 10 times t. So t is equal to 0.5 seconds. So that tells me that up here, this is equal to 0.5 seconds. Then I can find the y position. V naught y, t, 1/2 ayt squared. That's equal to 5 times 0.5, because I want to know y at the top. So I use t top minus 5 times 0.5 squared. One and a quarter, 1.3 meters. Okay, that's y. Now to find x, I say x is equal to vx times t. But recognize that x has t at this point, and at this point, that time is 1 second. I did twice this value. And so that's going to be my vx, which was 8.7, times 1 second, or 8.7 meters. That's like questions 1, 2, and 3 on your exam, or something like that. 1 and 2, I think it was 3 questions, but don't hold me to that. And on your midterm, on your exam 2, questions probably 1 through 4 on exam 2. Okay? Good question, Haley. You need, look, Haley, no, it's cold. You need to do it without even thinking about it.
I just I know there's a lot of implied variables that I forget or don't think about.
Yeah. Did you know that?
No, yes I do, but I didn't think about that because I was just I have nothing to go off of.
Right. But with practice you'll get this. Yeah, so you're right. There are some implied things. Vy at the top is equal to 0. This time is twice that time. Also, ax is equal to 0. That impacts how I write some of these equations. And I sort of assume, we assume that you know those things at this point, but I know that some of you, you're still processing some of these things too. Okay? All right, those are great questions. That's all for now. Oh, sure. Yeah. So they're only. Just take just. I know you already go, but just take F equals ma. There are the kinematics equations. Y equals v naught yt plus 1/2 ayt squared, and vy equals v naught y plus ayt. And then there are the x and y components, I guess. V naught x equals v naught cosine theta, and v naught y equals v naught sine theta. I don't really think of these as equations. It's just, applications of our trig. I think that's it. That's why you don't get an equation sheet. Chapter 5, there's a bunch of equations. They start coming back. So then you start getting an equation sheet. Okay? All right, y'all. Have a good